My name is Kaushik Yeturu, and today I'll be talking about ELR 6.7, which is to interpret heating and cooling curves in terms of energy. Now to start off, I'm going to be doing an experiment over the stove in which I'll be working with H2O, better known as water. Now, in a solid state, water is ice. So right now, the water, or the ice, is increasing in temperature. And, well, each layer of the ice is increasing in temperature, and after it's increased in temperature, up to 0 degrees Celsius, it turns into water. The temperature does not increase during the phase change, which is important, because the heat energy that's being conducted into the ice from the stove and through the pan, it can only be used for one thing or the other. It can either be used to increase the temperature of the ice and soon to be water, or it can change the phase of the substance, which would mean from solid to liquid or liquid to gas. And right now, the water is increasing in temperature, and once that part of the water increases to 100 degrees Celsius, it turns into a gas, better known as a vigorous boil. So I would say by now it's reached a vigorous boil, and it's going to be turning into a gas. And the temperature will not be changing right now because it's in the process of boiling, which is a phase change. Also, if I had used less ice, this process would have been faster. Reaching a vigorous boil, because with a smaller substance, less energy is required to heat it up, and also to do the phase change. Where with a larger quantity, more heat energy is required to heat the larger amount of substance and to change the phase of that whole substance. And now what will remain in this pan after this is done is the gaseous state of H2O and in the air. Okay, I'd say it's about done. Now to switch to notes. Okay, so now I have some important notes, and we're going to start with some vocab. Heat energy is energy used through energy passed through conduction, convection, or radiation. Temperature is a measurement of how hot a substance is, degrees Celsius or degrees Fahrenheit or Kelvin. A phase change is a change in state of a substance, meaning gas, liquid, or solid, changing between those. Heating is an increase in temperature. Cooling is a decrease in temperature. A heating or cooling curve is a trend in how something heats or cools over time, with a consistent amount of heat energy. Freezing is a liquid to a solid. Melting, a solid to a liquid. Boiling or evaporation is a liquid to a gas. Condensation is a gas to a liquid. And those are all phase changes, or the ones we'll be going over. Now, what we observed with the ice is shown here. Energy was increasing because heat energy was being conducted through the stove. As the energy was increasing, the ice increased in temperature pretty rapidly, And then at that point, it got to 0 degrees Celsius and it began to melt. and that's a phase change, melting. And notice how the temperature flatlined during that phase change. And then the phase change was over and it had all been melted. And at that point, it increased in temperature again from 0 degrees Celsius to 100 degrees Celsius. And once it reached that point, it began to turn into a gas, and it reached a vigorous boil. And then once that phase change was over, it would have continued to increase in temperature had I contained the gas and measured the temperature of the gas. Now, here are some important notes that you may want to take. Energy is pumped into water through conduction on a stove. The ice, or cold water, heats up, but the temperature does not increase during the phase change because the phase change uses all of the heat energy. Temperature rapidly decreases in heating slope when nearing a phase change. So, back to the graph. This would have been much more gradual than this graph is drawn. And freezing and boiling points vary by substance and energy used, and the amount of the substance. So, say I had used something besides water, like oil. Oil has a completely different boiling point and freezing point. So the results would have been completely different. And at the same time, if I had used more ice cubes or less, that would have changed how long the temperature rise and how long the phase change took. Generally longer. Thanks for watching. I hope you guys learned from this video.